Today's lesson is designing a survey. The objectives of the lesson are 1, that you will understand the concept of a statistic. 2, you will learn the steps in a statistical survey. 3, you will evaluate surveys, studies, and experiments, know the differences between them, and have some examples to take away from. Also, you will learn about sampling bias and random samples, as well as watch 2 short videos showing that subject. Understanding a statistical study. In a statistical study, data is collected and used to answer questions about a population characteristic, or parameter, as it is sometimes called. Since it is often impractical to measure an entire population, a sample or statistic is calculated. For example, say you were a producer of a new reality TV show and you wanted to find out how America thought about your new reality TV show, as well as their opinion of the characters. It would be almost impossible to sample all of the households in the United States to find out how they all really thought. So instead, you will take a sample, you will take a statistic of the population. So maybe you would choose 50,000 households or 100,000 households, as long as it was a random sample. Then you would collect your data, and then you would use that to make inferences about a population. For example, when you collect your data, you find out that most everyone in the households that you surveyed, at least 80%, did not like one of your characters. Perhaps they thought he was selfish or that he whined too much. So you would then choose to eliminate that character on a future episode, because you would infer that probably the rest of the population that's watching your show feels the same way. Let's look at this in a statistical study. Step 1 is identify your objective. What is it you're trying to measure? Maybe you're trying to measure on a scale of 1 to 10 how people view your new reality show. Step 2, choose sample and collect data. So you're going to choose who you want to sample. Perhaps you will randomly select 5,000 households in every state. Then you'll go about collecting that data. There's different ways to collect data. You can call the households, you could send out a mailer, you could set up a booth in a mall and collect information that way. There's many ways to collect data. Then step 3, you're going to organize the data you've collected and calculate sample statistics, like, for example, the mean, or the median, or the standard deviation. That's what we looked at last week. From that, you will make inferences. Step 4, you will draw conclusions about the population. So based on your data, you find out that most people do not like one of your characters. You're going to eliminate that character. Now let's watch a video about sampling bias. Wrong direction.
In 1936, the magazine Literary Digest predicted that Outlanders would beat Franklin Roosevelt in that year's election. The magazine based its prediction on 2,376,000 questionnaires, a huge sample size. The magazine drew the survey subjects from lists of automobile and telephone numbers. At the same time, a young man named George Gallup used a sample of 50,000 people and predicted that Roosevelt would win with 56% of the vote. Gallup's prediction was ridiculed as naive until the election. Roosevelt won with 62% of the vote, and Gallup's career took off like a rocket. The problem with the Literary Digest sample was the list was weighted in favor of those with enough money to buy cars and phones, a much smaller portion of the population in the 30s than it is today. The poll missed the large pro-Roosevelt sentiment among lower-income voters. This sampling design systematically missed a portion of the population, so it's an example of bias.
Okay, so now we've learned that to obtain good information and draw accurate conclusions, you need to obtain an unbiased sample. Another example would be if you're trying to figure out how people like football games, you wouldn't go to a football game and sample those people, since they're already at a football game, chances are they already like football games. But once you have an unbiased selection, it is then important to take a random sample. We've been talking about random samples. And this is a sample in which members of the population are chosen entirely by chance. So let's watch the results of this video to see when a sample is not random.
What, for instance, would you say the relationship is between the variables on this scatter plot? The answer, in this case, affected the lives of thousands of young men during the Vietnam War. In 1970, to eliminate what was called an unfair military draft, Congress decided to replace it with a random selection process, a draft lottery. The 366 possible birthdays were placed in capsules, drawn at random from a bin, and assigned selection numbers in the order drawn. Men whose birth date matched selection number 1 were drafted first. The next were drafted second, and so on. The drawing was supposed to be random, but it wasn't. Men born in December received systematically lower numbers and were more likely to be drafted. December 30th. The capsules had not been thoroughly mixed. The December dates, which were put in last, remained closer to the top and had a greater chance of being picked first. Let's see if we can spot the problem with the 1970 lottery by looking at its scatter plot. In previous programs, we learned the technique of smoothing, which is used to extract an overall pattern from a graph. We're going to use a common method of smoothing called a median trace. Here are the results of the lottery, with birth dates on the horizontal axis and draft numbers on the vertical axis. It's pretty hard to see a pattern in this cloud of dots. To get a clearer picture, we'll slice the scatter plot into box plots. Each slice contains 1 month of birth dates. Then we plot each month's median draft number. Now the downward trend late in the year is apparent. The men born in December had lower numbers and were drafted first. After the mistake in the lottery was publicized, the Department of Defense reassigned the officers in charge of the lottery and asked statisticians from the National Bureau of Standards to design a truly random selection procedure. In 1971, 2 drums were used. One contained birth dates, the other selection numbers. The capsules in both drums were thoroughly mixed, and then a randomly drawn birth date was paired with a randomly drawn selection number. If we compare the 1970 median trace with the median trace of the 1971 draft lottery, we can see a marked difference. While there is still variation in the result, there is no systematic trend in the 1971 lottery. It was a more fair selection.
Now let's look at some study types. There are surveys, experiments, and observational studies. A survey is data that's collected by members of a population. So when you're giving out surveys at a mall to see how people like your reality show, you're collecting data. An experiment is when you take a sample and you divide it into 2 groups, an experimental group and a control group. The experimental group is the group that you give the change to, versus the control group, you keep status quo. You don't apply a change to them, and then you compare the difference. In an observational study, you measure and observe your subjects without affecting them. Here's some examples. So here's an example of a survey. To determine whether the student body likes the new cafeteria menu, you ask a random sample of students their opinion. An experiment. A restaurant is considering adding sugar to their tea. They randomly give half their customers the tea with sugar and the other half the unchanged version. Then they ask how they like the tea. In an observational study, researchers at an electronics company observe a group of teenagers using different laptops and note their reactions. Do they seem frustrated? Do they seem excited? Does it seem easy to use? And that concludes our lesson. So by now, you should be able to understand the concept of a statistic. You should also be able to identify the steps in a statistical survey. You should evaluate surveys, studies, and experiments, know some differences between them, and then explain sampling bias as well as know how to take a random sample.